what is getting associated?
Yes.
But why is it unsupervised?
So it's unsupervised because why is it unsupervised? Because we're really just looking for combinations. We're looking for
All the possible combinations.
and it's not. Yeah, I mean it's sometimes all the possible combinations. It's just we're looking at the combinations, but there's no real. We're trying to predict this. So when you think about the idea of a target, the way we've used a target in the past is we are trying to predict this value. We are trying to use the data in this row to figure out, are you a 1 or a 0? Or we're trying to predict the actual value. Here we're not actually trying to predict anything. We're just looking for associations between all these different data points. So since we're just looking for associations, it's unsupervised. So we need a target, so yes, so it knows what things we're trying to compare. But in terms of supervised and unsupervised, it's unsupervised because we aren't actually trying to predict this thing. So for our data prep, with association analysis, data can come in a lot of different forms when you start to think of transactional data. Okay. So you think of point of sale data, a lot of times the easiest way to think about that is like on a receipt, right? And so when you think about it on a receipt, this is more like a transactional. What is a transactional data, right? So each record is going to be a single item. There is also a way you may see data presented in a tabular form. The tabular form, each record is going to be a separate transaction. Okay, so items are going to be flagged as ones for not, or zeros for not purchased, ones for purchased. Here, when you look at the tabular data, we're looking at, it's just if we purchased an item or not. It has nothing to do with how many we purchased. So it's like some examples. Here's just some raw data. So we went to a roadside stand, and at this roadside stand, we have all sorts of different types of vegetables. We've got broccoli, green peppers, corn, asparagus, squash, all sorts of different types of vegetables. And here's just a transaction. So the first person bought broccoli, green peppers, and corn. The second person, asparagus, squash, and corn. So we've got 10 different people who came and bought things. Raw data. The transaction data is going to, like I said, look more like a receipt. Okay? Transaction ID. So the first person bought broccoli, green peppers, and corn. The second person bought asparagus, squash, and corn. In terms of tabular data, each row is going to be a transaction. Here are the, 7 different items that we sell, and now we're going to say, okay, so row one, so person 1 bought beans, broccoli, corn, and green pepper. There's just different ways to represent the same data. Different data sets or different data software need the data in different forms to be able to run the association analysis. Okay, for us, for SASEM, we need the transactional data. So we need every item to be in its own row. So that's kind of how the data prep has to work. So how do you get the data? How do you get it in the format that you want? And now for the background of what's happening here with association analysis. So again, although we have to label a target variable, really our target variable is unknown. So we've got an unsupervised task. It's very data driven. So I'm not creating a model, I'm just looking for rules based on our data. And our big goal is we're just looking for association between items. It could be between events, but a lot of times it's items using transactional data sets, resulting in a set of decision rules. That's our big goal. What rules can we find? What insights can we find? It is the study of what goes with what. Okay, so when we were thinking of clustering, it was kind of like who goes with who. Right? We're trying to cluster similar people together. Here it's what goes with what. Right? So customers who bought X also bought Y. To take like kind of a step outside of the box, it could be what symptoms go with what diagnosis. Right? So you kind of get into the medical field. Or what tests are often run for symptoms. Or what tests go with certain diagnoses. Like I said, it's also called market basket and affinity analysis. Fun question there. It is a transaction-based or it's an event-based algorithm. So it originated a year ago, kind of with customer transaction databases. really we're trying to figure out it's what goes with what. It's the big idea behind association analysis. If I can figure this out, if I know more what my customers are buying, I can think about how I can set up my store. I can think about how I purchase things, how I package things. Right? So the first time when I actually took this class, you go to the supermarket or the grocery store, whatever, all the time. Do you pay attention to what's next to what?
Sometimes.
Sometimes, yes, sometimes no. Right, so I hadn't as much, but then I was like, we were learning about association analysis. It's like, that happened to be the time, I think it was like April-ish, and I walk in, and I go to like the produce section, and there was bacon in the produce section. I'm like, what's a bacon in the produce section? It's not. I love when you're like all kind of healthy and like next to the asparagus. Bacon or asparagus. It was next to the lettuce and the tomatoes.
Yeah,
To make a BLT, right? A bacon, lettuce, tomato sandwich. Right? Very popular Midwestern cuisine here. But I walked in and I'm like, why is this? And then I looked and I'm like, oh, like, and it all made sense. And I'm like, somebody must have taken this class too. So, but association analysis is somewhat kind of the basis of all of our wonderful recommender systems. Right? How many of you love, I don't love it, but you like, right? You're like, Amazon, I just purchased a book, I just purchased a CD, you guys even purchase CDs anymore. Okay, I just purchased something on Amazon, and it's like, hey, customers who bought this title also bought, here's some suggested things. Right? So you bought this, here's what other people bought. Right? So if you buy X, you're likely to buy Y. So now it's using all of this data. Netflix, right? Again, it's not a strict association analysis, but it has kind of these ideas, these recommender systems. It's like, hey, this is great, you like this, you'll probably like this other thing too. So an idea of association rules. There's really three big kind of groups of rules. We've got the actionable rules, which is what we're looking for. Right? So Walmart customers who purchase Barbie dolls have a 60% likelihood of also purchasing one of 3 types of candy bars. It's actionable. I can do something with that. Put candy in the toy aisle. Why not? Or what do you put between the candy and the toy aisle? There's different ways to think about it. You can be actionable about it. Trivial rules. Customers who purchase maintenance agreements are very likely to purchase a large appliance.
Question.
Are you going to purchase a maintenance agreement just for the fun of it? Probably not. Right? So if you purchase a large appliance, then you may have a maintenance agreement. Probably not the other way around. The inexplicable rules. These are always fun. A new hardware store opens. The most commonly sold item is toilet cleaner. Who knows why? Right? So it's inexplicable. You're just like, oh, okay, that's cool. Right? So we're going to create a lot of rules. The larger our data set, the more rules we're going to create. So the question then becomes, are they all good rules? No. So we've got to have some still kind of overarching principle that's going to guide us, and really we're going to do it through these actionable rules. So we've kind of already talked about this with our decision trees. All of our rules are going to be in the form of if, then. Okay. We've got an item set that's basically going to be the group of items or products that are going to be in the antecedent or the consequence. So that's basically saying it can be if one thing, then another. It can be if 2 things, then something else. It can be if 5 things, then these other 2 things. So there's no real limit on how many items can happen in the antecedent or the consequence. The only thing that is important is those 2 things have to be disjoint. Okay? We can't have if bacon and asparagus, then asparagus and corn. Right? Those 2 things have to be disjoint. So there's a couple of different ways that we can go mining for rules. I'm not going to get into the details of really how this is going to work, but kind of the idea is that you don't necessarily want to just like mine for all of the rules, right? You want to find the rules that are the most frequent, the ones that are the most useful, the ones that are most common, right? So you can look at these frequent item sets, and when I say frequent, like you kind of like set this cutoff. Like this has to happen at least 10 times in my data set, or this has to happen at least 100 times in my data set, depending on how much data you have. Right? And if it happens at least 100 times, then I'm interested in it, and then let's keep looking about it. But if especially like if I'm a smaller store, and I sell some specialty items, if I'm only selling this item like once a month, then I probably don't want to look for associations with that one item. I want to look for things where like this item sells at least 100 times. Now let's see what else it sells with. This a priority property basically kind of goes the idea. So what this is going to do is it's going to reduce the number of the search space. So it starts out and says, if you fit into this criteria, so if an item set is not frequent, then the union of that item with another item isn't going to be frequent either. Right, so this item is only selling once a month, and even when you group it with another, then this idea of these two items together still isn't going to happen a lot. So if it didn't happen once, adding it to another item is still not going to happen a lot. Okay, so the idea is just to like get rid of as much of that as you can. And so that's going to be kind of a setting that we'll have on SAS that we can keep. But really, because we can, even with really large data sets, the association analysis runs fairly quickly. We can get a whole lot of rules. And then we just have to sort through them and find the ones that are actually actionable. So a couple of things to think about when we're building our rules. There's going to be the grain. You guys talked about grain in your database portion. This week.
Yeah, we didn't have class Monday.
Class you didn't have on Monday. Yeah. Okay. So this happens to me all the time. I'm like, hey, there's this thing. And they're like, yeah, we're going to learn that this afternoon. And you guys are like, oh, we would have learned it, but we didn't. So the grain is basically just saying here, are we interested in pizzas or are we interested in pizza toppings? Right, so you have to make sure that you're looking at things at the right level for us to be able to make associations. So are we looking at pizzas with all the different toppings on them, or are we just interested in individual toppings? Okay. We're going to calculate probabilities. This is the one time you guys are actually going to have to do some calculations. I have some smiles and I have some frowns. So, and then we'll look at the probabilities, and that's going to help us decide what our rules are going to be. So again, how are we going to decide if our rules are good or not? Should we use them? Should we not? So again, we've got this if-then. We have support, confidence, and lift. Talked about all three of these in relation to other data mining techniques. Here's my big, fun, official definition slide. Basically, I'm going to tell you what they are. So the support for the rule is just how often the rule happens in the data set. How many times did we actually see this rule in the data set? It's measuring the overall impact. The confidence for the rule is how accurate is the rule, right? How confident are we that this rule, if we used it again, would still be there? Okay. So it's the rate at which the consequences are found. How confident are we? It's the accuracy of the rule. At the top right here is the expected confidence. We don't actually really talk about it, but we need it to be able to make a calculation for the actual lift. So the lift is talking about the confidence, and then we divide that by the expected confidence. Right? So the expected confidence is how many times we would expect to see the then part, the consequence, happening overall in the data set. And so then we look at the confidence for the rule divided by how many times do we just expect to see this happening in our data set in general, and that's going to give us the lift. Have we seen lift before? Lift charts, right? So similar idea. When we're looking at our lift charts, what was kind of our baseline cut? Like what was that value we were going to look at? If it was above a value, then we're like, oh, this is good lift. If it was below that value, we were like, eh.
50%.
So 50% is for the gain.
Oh.
But so like if I have a lift of 5, that's a good lift. 5, 1. So 1's my baseline, right? So because if I have the exact same percent of confidence over the exact same percent of expected confidence, that's 1. Okay? That hasn't really done much for me. But if my confidence is higher than my expected confidence, now my fraction is going to be above 1, which means I'm getting the rule more than I expect to get. Okay. And so that's going to be the lift. In general, we want high support and high confidence. Both is even better. The high is a very relative term. Okay? So if we have a supermarket items purchased together, we're talking about a supermarket. The support, again, is how many times that rule happens overall and out of all the transactions. So getting a support of 20% is actually really good. That's saying that this rule is happening. People are buying X and Y together 20% of the time. Now the confidence here, we want that to be really like at a higher confidence. So it may not happen, right? 20%. It's not happening a lot in our data set. But when it does happen, if they do buy X and they're going to buy Y, and we're 70% confident about that happening. Okay, so we've got a higher confidence. When we talk about fraud detection, how many times do I want to see fraud in my data sets? None would be great, right? You don't want to see fraud. So would you expect to see these rules happening a lot? Hopefully not. So the support is very small. It doesn't happen in the data set a lot. Okay? But when it does happen, if we're able to say if X, so if this behavior happens, then fraud is going to happen, we can get that right 50% of the time, then that's a good thing. So that's kind of the idea about these rules of the support and the confidence. We try to have high support, so the more it happens in our data set, the better. And then we really want to have high confidence where when one thing is happening, the other thing is following a high proportion of the time, a high percentage of the time. So let's see how this works. Actually doing some of the math. Yes?
So in real life, like Amazon suggestions, I would probably think that the confidence would be like 30% or 20% rather. I don't think there will be. If it's 70%, then most of them we would really find that useful, right?
Right, yeah. So we'll do is the Sam's Club data set here in a minute, and you'll start to see that like the support is minuscule. But the confidence, depending on what it is, can get pretty high. So for some places, I mean, you'll get confidence of 50 to 70%, and you're like, yes. I think I actually have one example where the confidence is almost like 90%. It's pretty cool. But again, the support for it, because when we're talking about 40 million records, we're talking about 70 million records, even if it happens a lot, it's still happening a very small percentage of the time. All right, I'm going to try to do this and see what's happening. So here I just have 5 customers in a very small data set. Customer 1 bought some pen and pencil. Customer 2, pen, ruler, and tape. 3 has pen and tape. 4, pen, pencil, tape, and candy. And 5 has ruler, tape, and candy. So we have this chart to kind of help us make our calculations a little easier. So what I would fill out with this chart, so I would say, how many times did we buy a pen? Looks like I've got 4 times that I bought a pen. I'm just going to fill out some of this. How many times did I buy a pencil? 2 pencils? So I'm going to do red. How many times did I buy a pen and a pencil together?
2.
1, pen, pencil. So actually, if you go through and fill all this out, how many times did I just buy candy? How many times? And if you do it and you trust my numbers, then all right. If that's where those numbers came from. So then the question is, okay, well, let's pick a rule. So my rule is going to be if pen, then tape. So if we go back to here, so we've got pen is blue, tape is tape, 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 tape. So I've got tape and tape, right? 4 of those, that doesn't help. And let's do, well, colors. Let's do pen and tape. How many times do you pen and tape out this week? 1, 2, 3. So 3 times for pen and tape. Alright. So if we were going to do the support is how many times, how many records do we have where we have pen and tape together out of the total number of records? So we have 5 records total. How many do we have pen and tape together? 3. So 3 out of 5. So 60% of our records have where you bought both pen and tape. So pen and tape occur together 3 times out of 5 total transactions. So if you look at that on a bigger scale, if we have 100 baskets, then we can expect 60 of those baskets to have both pen and tape in them. That's how you would interpret the support. Easy enough? The confidence. So this is where the number of records for both the antecedent and the consequence, and we're dividing it by the number of records in the antecedents. Antecedents part at the beginning. So that means how many times do they happen together? So how many times do you have both pen and tape? Three. Very nice. It's one of the red highlights there. And then how many times do we have pen all by itself? 4. So 3 times we had pen and tape together. 4 times we had pen all by itself. So 3 out of 4 times if somebody bought a pen, they bought tape as well. So if the basket contains a pen, there's 75% probability that it's going to contain tape. That's what the confidence is telling us. So it's going back to the probability that your basket has the first thing in it, that it's going to contain the second thing. So just really quickly, just because we need this for our next calculation, we need the expected confidence. So here, if you just bought tape all by itself, you buy tape all by itself 3 out of 5 times. And that's our expected confidence. And then to calculate our lift, we're going to take the confidence that we've already calculated, so that's 75%. We're going to divide it by the expected confidence, which was 60%, but 3 out of 5 times. And we end up with 1.25. So if we have a basket that's going to contain a pen, it's going to be 1.25 times more likely to contain tape than a basket without a pen.
The consequence. It's just tape alone.
Yeah, so just tape. So the consequence in this case is just tape. So how many times does tape happen without anything to do with pens? No, so the tape happens 3 times out of the total number of records. Right, so 5 people went shopping. Of those 5 people, 3 of them bought tape. So regardless of if they bought a pen or not, 3 of them bought tape.
It doesn't matter what they bought.
Right. So for the expected confidence, it's just about what happened in that consequence. So at the end, what happened? So people buying tape, we had 3 people buy tape. It doesn't matter what else they bought.
If it's just, if they bought it, it's a political.
Written the consequence. Not necessarily.
Yeah, I see what he's saying.
I think every year I scribble this out. fix this. 4 out of
Because
5. Yes, no, you're
it's-
totally right.
no, it's just. But I was a little bit. But it's just did they buy tape? It
It's just
doesn't matter
did they
what
buy
else they
tape.
bought. Okay.
Right, it doesn't matter what else they bought. So I just wrote the wrong number. So 4 out of 5, 80%. 4 times out of 5 total. So then this is going to be 4 out of 5. That's not what I wanted. So that's going to be less than 1.25.
29%.
And that happens for if tape and pen. You guys make me think. Like I felt so confident when I ran over this last night. I'm like, oh, I got this. This is great. So if the pen, then tape. The expected confidence. Let's go back to. Here we go. So it's the number of records of the consequence divided by the total number of records. So I think it actually. So I'm going to take back how I explained it. So it's the number of records in the consequence. So it really is the 3 out of 5. So it still has to do with, because if you didn't have a consequence, so if you said it was the 4, then that has nothing to do with pen. Right, so so it's still going to be the number of records in the consequence. So it is still going to be, for the pen row, how many times do you get to? So it's, yeah, so that's a good point. Right. Because if you wouldn't have, there wouldn't be a consequence if you were just looking at it in general. So the consequence has to happen in conjunction with the antecedent, so it has to be the 3 out of the total number. Yes.
And the 5 is just the number of items there?
So the 5 goes from, we have 5 customers.
Oh, okay.
Because it's the total number of records. So we have 5 customers. So since it's the confidence, since it's the consequence, it has to be the number of tape inside the number of pens. That'll be 3 out of 5 times. That'll be the 60%. Which still leaves that correct. So in this case, a basket that contains a pen is 1.25 times more likely to contain tape than a basket without the pen.
So then, are the support and the expected confidence the same thing?
They are not, because the support is just how many times it happens throughout the entire data set.
So the support is like the number of records, but the antecedent and the consequent divided by total number of records. So that's
Right.
3 to 5. And then expected confidence is number of records of the consequent, which is also 3. I just like how it was different. Okay.
Let's do the next example. Let's see if what's the same and what's different, and then let's come back and have this conversation.
Okay.
Because I think that may. So if we switched, if tape then pen. Okay. So my first one was if pen then tape. Right? So now if we go if tape then pen. Then support is still going to be how many times total does tape and pen happen at the same time? 3 out of 5. That support doesn't change. If pen then tape, if tape then pen, support doesn't change. The confidence, right, is going to be. Right, Alright, so confidence is the number of records in both the antecedent and the consequence divided by the number of records in the antecedent. So how many times does it both happen? It happens 3 times. And here the antecedent is, I probably should come up with different numbers. So again, we're still looking at 3, but this time we're looking at this 4. Now we're going to be looking at the expected confidence. So the expected confidence is what's happening in so I want this to be 4 out of 5. So this is what's happening in the consequence. So really what happens is I just need some better numbers to make this different. Because this should actually still be 3 out of 5. And it doesn't change.
The expected confidence.
And this is where you guys benefit when I teach the Saturday class before I teach you. Okay. Let's go back and try this again. Alright. So what I'm going to do, let's do this. Let's take... Let's do this. Let's get rid of, since we're talking about pin and tape, let's take tape out of this option. Okay, so if we take tape away, how many times, we're going to start over. We're going to all have this nice conversation. Let's get rid of this tape. So how many times do we have pins? Okay, so we're still happy with that. Okay, 4 pins. How many times do we have tape? So now we have 3 tapes. How many times do we have pen and tape? Got pen and tape here, and pen and tape here. Okay. So now all the numbers are different. So now hopefully we should be able to make this happen. So that would change that to 4, 2, and 3. Okay. So that makes 4, 2, 3. So if we're doing the support, if pin, then tape. So how many times do we have both the antecedent and the consequence? So, okay. So we got 2 times out of 5 total records, 2/5. 40%. So pin and tape occur together 2 times out of 5 times total, 100 baskets, 40 pin and tape. Okay. 2, 3. So the confidence, the number of records, both the antecedent and the consequence. 2 here. Total records in the antecedent. 4. Alright, so we got 50% here. So 2 times out of, that's part 6, out of 4 times. So now if the basket contains pin, 50% probability is going to contain tape. We're all happy there so far. So now, expected confidence. The number of records in the consequence. We've got 2s and 3s, right? So the number of records in the consequence is 2. No, 3. 3. So this part's actually right now. Okay, so now 3 out of 5. Because we're just looking at the consequence. The only thing in the consequence is the tape. Out of the tape, we get 3 out of 5. this is really the one that should be highlighted, not this. We're doing 3 out of 5. So then if we take this here, our confidence was 2 out of 4. We kept the 3 out of 5. That gives us 50 out of 60. And we're going to get no lift.
$87%. Only 87% is likely, not over time.
Right. So here, that's not what we would say. So we would say something more like this. Customers who buy tape are only 84% as likely to buy pens. In this case, it would be customers who buy pens are only 84% as likely to buy tape than customers in the entire data set. Customers buying pens. 84% likely to buy tape than, I say, the general customer. So really, now let's go back and actually look at this, right? So if you buy a pen all by itself, you're doing that 4 times. If you're buying tape all by itself, you're doing it 3 times. But buying them together, you're only doing it twice. So really, if we think about how this is working, right? Think about market basket. If I buy X, then I buy Y. Okay. So if somebody is buying tape, and they just bought tape, does really having a pen, is that helping? Is that adding to? Are we getting a higher percentage of people who are buying not just pens by themselves, but pens and tape? No, right? So you might as well just buy tape all by itself. Because by knowing that you buy pen, that's actually a smaller number. So ideally what we would be looking for to have a lift would be, we would want somebody who has pen, or who buys tape, so 3 people are buying tape just because they're buying tape. If pen and tape were 4, that's when our lift's happening.
So you
Which
want
wouldn't
to
make sense though. That one doesn't make sense.
find a combination that's higher than where it's
Man, I've got
pen
to...
and tape and tape.
Right.
You want the numbers above it to be higher than the number at the bottom. The way that
But
that
it's,
table
which
set
wouldn't
up.
happen though. Right, because we're talking about pen all by itself, we're talking about tape all by itself. What happens if we switch this? Does it matter? So if tape then pen. Let's see if that changes anything. Okay, so now this one's 2, and this one's 3. What happens? So the support, how many times do we have? So this comes to 2 out of 5, which is 40%. So the support didn't change. The confidence in this case is going to be what? So remember, confidence was, go back, both the antecedent and the consequence divided by the antecedent. So we want both pen and tape. And this time the antecedent is tape. So here we had 50% confidence. Here we have 67% confidence. So the confidence can change depending on the order of your antecedent and your consequent. That is the big take-home message that I tried to do that didn't come across well in slides.
What was the previous one? I know you just said.
So it was 50%.
Okay, so it went up.
So in this case it went up. In some cases it'll go down. right? But it can definitely be different. So if one thing then another does not give you the same confidence as if, so if X then Y does not give you the same confidence as if Y then X. It can, but it doesn't have to. Fun quiz question. So if we figured out the expected confidence, let's go ahead and try that. Let's see what we come up with here. So the expected confidence, going back, so here it's going to be the number of records in the consequence divided by the total number of records. So how many are in our consequence?
2.
So here,
Oh, it's 4, yeah, because it's at the end.
right, so it's actually, so this part stays the same. So this is still good. We're still good with that. And then for our lift, so now we've got the 0.67 over, which is still not great lift. So basically, instead of giving you a good rule and a bad rule that I tried to make work, I just gave you 2 bad rules. I feel like we need a break after that. So let me tell you the rules that were the things we need to be cautious about, and let's take a break. So one of the things we need to be careful about when we're creating our rules is that random data can give us some associations, right? So if you have a lot of data and we're looking for associations, we can find things that aren't really there. The more rules you produce, the greater this danger is. However, when we have a large number of records, then we're less subject to this danger because now you're going to have more and more data. So the more and more data that we have, then we're going to be able to see, oh, this is happening a lot. So when you have smaller amounts of data, you're trying to find associations, you can find basically some noise. The more data you have with association analysis, the better, because then you have more support for each of your rules.